Hello, I'm Raj Anthony,
I'm Jason Yang.
and we're members of Team Animos, a senior design team of 8 people here at Rice working to build a new and updated wind tunnel for Rice's design labs. Now, why do we need a new wind tunnel?
To help explain that, it might be easiest to just, look at Rice's current wind tunnel. And it has been Rice's current wind tunnel for the better part of 4 decades. And as you can see, it's getting a little bit deprecated. To control the wind speed of this wind tunnel, you first have to adjust some knobs and flick some switches on this controller here, then cross-reference it with pressure readings on these gauges, and then take that all the way back here to look at these pedostatic differential pressure graphs, and then back calculate your wind speed that way. And this process has been described by mechanical engineering students who have to use this wind tunnel for their aerodynamics and fluid dynamics labs as both imprecise, non-intuitive, and difficult to use. Furthermore, looking at the size of the testing chamber here of the wind tunnel, you can see that it is just barely over 1 foot. And this really narrows the scope of what can be placed into the testing chamber and what can be tested. And additionally, there is only one mounting apparatus that doesn't allow for much flexibility. Now, coming around to the front of the wind tunnel, you can see here that the intake is not only very short and very steep, but features no flow straightening whatsoever. This makes it such that there is no way to verify the boundary layer conditions around the edges of the testing chamber and does not ensure laminar flow, which is a core component of accurate and stable testing. Whereas the wind tunnel we, Team Animos, hope to design will feature a cross-section 4 foot by 4 foot in area and additional controls that will be intuitive and easy to use. We want to have fully integrated instrumentation and built-in data collection and digital control interface that will allow anybody to come and use this wind tunnel.
Yes, and it's already going to start helping. One of the major ways it's going to help right now is with Rice Wind Energy. Rice Wind Energy is Rice's U.S. Department of Energy's Collegiate Wind Competition team, and we are actually now nationally ranked. But the major issue is that we're not able to fit our wind turbines in the current tunnel here at Rice. This is our 2024 turbine, and as you can see, it just doesn't fit inside the tunnel. And so having a tunnel at Rice that is able to support the needs of Rice Wind Energy will be crucial for the team, for one, because it's really the only way that the team is able to test their turbines' designs before the competition, but also it will help cement Rice as a school that is a leader in the renewable energy transition for years to come. But, as mentioned before, this wind tunnel won't just help Rice Wind Energy. This wind tunnel, now built for the 21st century, will help students and faculty from across the Rice community build the best innovations they can. It will provide them even more speed, flexibility, and precision in every test that they do.
And just to reiterate one more time, we hope to build something that will be at the forefront of driving innovations in renewable energy development and research and be a valuable asset to labs and student research and design and academic understanding at Rice for years and years to come.
We also plan to add support for modular test sections so that larger test sections can be swapped out for smaller ones that would allow for the wind speed of this wind tunnel to exceed that of the current wind tunnel.
As we want our wind tunnel to be a lasting piece of equipment for Rice, as able to last 30 plus years, this project will require more than the $2,500 that senior design teams are given to start. We estimate that our total project cost will instead be around $45,000, based on our research of components and materials required thus far, as well as an investigation into the cost of a very similar wind tunnel built by another senior design team who we've been in contact with. This price is much cheaper than what Rice could buy a similar wind tunnel for. Through conversations with pre-built wind tunnel manufacturers, we have found that a closed circuit wind tunnel of our same dimensions would cost around $1.5 million. And we estimate from our research that a pre-built open circuit wind tunnel of these same dimensions would be quite expensive as well, reaching into the hundreds of thousands of dollars. Our team has the passion, and we have drawn up the designs. The last piece we need is your financial help to bring this impactful project to reality before we graduate. We are super excited not only about how this wind tunnel will help usher in a new era of aerodynamics and sustainability advancements here at Rice, but also how this project perfectly aligns with Rice's new strategic plan as well, given the plan's strong focus on undergraduate research and sustainability. We would greatly appreciate your help in funding this project, as every little bit will make a big difference in making this project possible. We're happy to answer any questions you may have or provide any more detail as well. Please don't hesitate to reach out to us at teamanimosrice@gmail.com.
why not just travel to other institutions that have a wind tunnel? We have also considered whether Rice engineering teams, like Rice Wind Energy, would be able to test their assemblies elsewhere for a larger wind tunnel size and more precise wind speeds. On this note, Rice Wind Energy is already in contact with Texas A&M, who allows the team to test part of their turbine setup in their low-speed wind tunnel. However, this solution faces 3 key issues. First, performing tests at Texas A&M requires a full day and intensive planning. Since it takes time to carefully pack equipment and travel almost 100 miles one way, testing is not always feasible in account of students' demanding academic schedules. With the functional wind tunnel at Rice, teams can test anytime they have a model ready, instead of waiting to justify time-intensive travel. Second, no Rice organization is guaranteed access to the Texas A&M wind tunnel. If any accident occurs within the wind tunnel, such as a blade accidentally breaking inside the tunnel during the testing process, we cannot guarantee that Texas A&M will allow Rice Wind Energy or any other Rice teams back. Furthermore, other Texas institutions, like the University of Houston and the University of Texas at Dallas, have denied requests from Rice Wind Energy to use their wind tunnel, which means that this club heavily relies on the benevolence of Texas A&M. Third, Texas A&M cannot always meet the needs of Rice clubs. For example, Rice Wind Energy needs to test its turbine in an offshore simulation tank, which is a roughly 1 meter cube tank of water. This would be difficult to set up at any other location, let alone a wind tunnel. Therefore, figuring out the logistics of filling and maintaining a tank of water would not be feasible for a university outside of Rice, such as Texas A&M. While these are issues that have been faced with Texas A&M wind tunnel, they can also apply to any wind tunnel not owned by Rice, regardless of the location.